Now we're doing the fancy wheel grid animation, which starts out at step 0 looking like this. 1, 2, 3, 4, 5 rows, 1, 2, 3, 4, 5 columns. Again, do not hard code that number 5, neither for rows nor columns, but put them into well-named variables, so it would be really easy to change that to, say, 4 by 4 or 20 by 20. They fill the entire canvas, and inside this grid we are placing these fancy wheels. Okay, now a fancy wheel is really not a wheel at all. There's nothing round here. There's no circles being drawn here. Everything that you're going to draw in this problem is only a line. Everything here is made up of lines. Okay, so you start out in the left top with a four-sided polygon, a square, although it's rotated. And then the way you draw this is you connect every single vertex to every other vertex. You can see that plainly going on here. As you get one step away in either direction, you go from 4 sides to 5 sides. And now you have to draw a 5-sided polygon and connect every vertex to every other vertex. And then when you go one more step away, you have your 6-sided polygons here, and your 7-sided here, and so on, 8, 9, 10, 11, 12. Okay? Note when you're drawing these that you could imagine a circle around the polygon, and you'd realize that the vertices sit on the circle. So this is how you can determine the points, the vertexes. What you do is you compute the angle off the horizontal. Like here's your horizontal. You compute this angle. It's pretty easy in this case because, like, for instance, there's 6 total vertexes. 360 degrees around. 360 over 6 is 60. So that's the angle off to that vertex. You've got a radius you're going to have to figure out on your own. You've got a center you're going to figure out. Center, radius, and angle, voila, you can figure out that point. So now you figure out all the points of the vertices and you connect them all. That's how you draw these things. What's really cool is, as you see down here, some circles seem to emerge from these drawings, but we're not drawing circles at all, just lines. Okay, the next thing is the colors. So what you're going to do is everything in the top row is going to have no red, and everything in the bottom row is going to have full red. Everything in the left column is going to have full green, and everything in the right column is going to have no green. So as you move this way, the green goes down, and as you move this way, the red goes up. The net effect is the first row has no red, so it's full green here, no green here, so this one's black. This one down here is full green and full red, and it turns out green plus red equals yellow, which is why this one is full yellow. The next thing is rotation. As we step, these are going to rotate. Actually, let's have it go for a moment. There you go, rotation. Some computers are faster than others. If it doesn't rotate this fast in your computer, don't worry. Let me now pause it, and let's see the rotation in action again. Actually, I'll reset. And as I step, take a look at the first one, the square. As I step, you can see it's rotating clockwise, and I'll tell you it's on every step, the vertices have to spin 10 degrees. So 10 degrees. So if I were to click this 9 times, it would have rotated 90 degrees, which is why it looks like the original again. So there you go. Now this one's rotating clockwise. These two are rotating anti-clockwise. See how the pentagons are rotating anti-clockwise? And then the hexagons are rotating clockwise in. And now when I say go, you can see that all of the even-sided or even number of vertex polygons are rotating clockwise, and all of the odd-sided ones are rotating anti-clockwise. And that is that. Good luck.